Okay, so if you've been on social media at all lately, you have probably seen it. These absolutely incredible photos of the northern lights popping up in places you would just never, ever expect. It really seems like everyone is suddenly catching a glimpse of this amazing celestial show.
So that's the big question, right? Why all of a sudden? What is going on? Well, in this explainer, we are going to break down the science, the timing, and, most importantly, exactly how you can get in on the action. Okay, let's dive right in.
And look, when we say everywhere, we are not kidding. This isn't just for folks in Alaska or Norway anymore. We're talking recent confirmed sightings in places like Colorado, Illinois, and get this, even as far south as Texas and California. This cosmic light show is seriously expanding its territory, and we're about to find out exactly why.
To really understand what's happening here on Earth, we've got to look about 93 million miles away, to our sun, because that's where the secret recipe for this entire spectacle is being cooked up.
So the fancy name for it is Aurora Borealis, which is just this beautiful Latin phrase that means northern dawn. And at its heart, it's a really simple, elegant process. Charged particles shoot out from the sun, they collide with gases in our atmosphere, and bam! That collision creates light. You can almost think of it like a giant, planet-sized neon sign getting switched on.
Now, this is really important to understand. Not all solar events are created equal. On one hand, you've got the solar wind, which is kind of like a constant, gentle cosmic breeze. That's what gives us the regular, predictable auroras you see way up near the poles. But then you have something called a coronal mass ejection, or a CME. And that, my friends, is a solar hurricane. A massive, violent eruption that hurls a ton of energy right at us, supercharging the whole process and pushing those lights much, much further south.
So let's trace the journey, step by step. It all starts when the sun basically burps out a huge stream of charged particles. From there, they ride that solar wind all the way across space to us. As they get close, Earth's magnetic field, which is kind of like our planetary shield, grabs them and funnels them down toward the north and south poles. And for the grand finale, they slam into the gases in our atmosphere, releasing all that energy as light. And that is the show.
So what about those incredible colors? Well, they're not random at all. The color depends entirely on which gas is getting hit and at what altitude. That brilliant green we see most often, that's from oxygen particles getting all excited at lower altitudes. If you see red, that's oxygen way, way up high in the atmosphere. And those beautiful blues and purples, well, that's nitrogen getting in on the action.
Okay, so now we know the science behind it. Let's get to the fun part. How do you actually become an aurora hunter? It's all about learning to read the cosmic weather forecast. Think of this next section as your treasure map to the lights.
So, the number one reason this is all happening right now is timing. The sun has this roughly 11-year cycle of activity, and we are currently approaching what's called solar maximum for solar cycle 25. That means the sun is more active, it's a little angrier, and it's throwing more of those CMEs, those solar hurricanes, our way. This is the single biggest reason the auroras are so frequent and so intense lately.
Now, if you're going to hunt for auroras, there is one number you absolutely positively need to know, the KP index. It's just a simple scale from 0 to 9 that tells you how intense the geomagnetic activity is. Low numbers mean things are pretty quiet, but high numbers, that means there's a storm brewing and it's probably time to get outside.
And this table breaks it down perfectly. A KP index of, say, 1 to 3, you'll probably need to be in Alaska to see anything. But when the forecast calls for a KP of 5, that's a G1 minor storm, and the lights could be visible all along the northern US border. But then you get to a KP of 7 or higher, now we're talking a strong G3 storm, and that's when places like Illinois and Colorado get to join the party.
So where do you get this information? Well, you can go straight to the source. NOAA's Space Weather Prediction Center is basically the National Weather Service, but for space. Or, if you want the forecast to come to you, there are some fantastic apps, like Aurora Alerts, that will literally send a notification to your phone telling you it's time to go look. It has never been easier.
All right, you've checked the forecast, the KP index is high. It is officially go time. Let's get into our final section here and put this all together into a practical checklist for your own aurora hunt.
This is it, the moment of truth. You've done all the research, you know the science. Now, how do you maximize your chances of actually seeing this incredible phenomenon with your own 2 eyes? Here we go. 4 simple but absolutely crucial steps. First, and this is the most important one, get away from city lights. Light pollution is the #1 enemy of aurora viewing. Second, check that forecast and aim for a KP index of 5 or higher. Third, you gotta be ready to stay up a little late. The peak viewing window is almost always between 10 p.m. and 2 a.m. your local time. And finally, just face north. The show will typically start on the northern horizon. And this right here is such a critical piece of advice. The aurora doesn't run on our schedule. It can appear in these faint, shimmering bursts that slowly grow in intensity, so find your spot, let your eyes adjust to the total darkness for at least 15 minutes, and just be patient. Trust me, the reward is absolutely worth the wait.
This chart really just drives that point home. Yeah, you might get lucky earlier or later, but your absolute best odds are in that window right around local midnight. That's when your spot on Earth is positioned perfectly under the heart of all that auroral activity. So, the main thing to take away from all this is that we are in a really special moment. Thanks to the peak of solar cycle 25, the chance to see the northern lights from so many different places, it's a rare opportunity. Seriously, it's one that won't come around again for about another decade.
It really makes you wonder, doesn't it? As our sun's activity continues to build toward its peak, what other spectacular sights are just waiting for us right above our heads? All we really have to do is remember to look up.